PEP.
Okay. So we are going to start our lesson today. We have lots of materials haven't covered last time, so we'll cover it first. Okay, uncovered materials. So basically, we haven't covered this one. Okay, so what you have to remember is frequency below 146, most of them are primary use, and for frequency higher than 146, which is 330 to 81,000, most of them are secondary use. Okay, so you have to remember the whole frequency, and which of them are for primary use and which of them are for secondary use.
Do they accept?
Yes, exactly. But your questions are in MC, so they will give you a range. So you don't have to memorize every digit, but just a range is enough. Okay. And what you have to remember is the max power in dB watt, and the class of emission permitted. But for the class of emission permitted, you will see that for all the frequencies, they share the same class. And I will explain the details of them. There is one exception for 330 this band, this one, the first class. You will see that there is a little star besides the carrier, the maximum power of the carrier wave, which is 14 and 7. The 7 is for mobile and portable. We call the handheld radio as portable, and for mobile it is 14 dB watts.
And 20 is for fixed
20 is for, yes, or not fixed station, but or fixed station. Yeah, fixed station. Okay. So before we go to explaining, you see here is a carrier and PEP, right? So I'm going to explain what is a carrier wave and PEP. Okay. We'll go to deeper details when we go through the modulation. But you will see that carrier wave is oscillation that's to carry your signal. Okay, so for the signal you really emitted, it is a combination of the carrier wave and the message wave, which is you will see that the amplitude modulated wave. So this is an example of AM, amplitude modulation. And the PEP is the maximum amplitude of the combined wave. Okay, so you see that carrier wave is a frequency we are designed to transfer, to emit, and the message wave is the voice that we put it in our daily messages. When we combine them, we'll have a modulated wave. Yeah. So you see that the frequency the carrier wave, that is the frequency that you decide to use. You have to follow the left column in left, which is the carrier wave here. And for modulated wave, which is the PEP, you will have to follow this here, which is different. So you will be careful. And why you have to divide it into two? Because sometimes when your voice is really loud, and which is the message wave you put into carrier wave, you modify the final signal, the final wave outcome, and the wave may be very the frequency may not the frequency, but the amplitude will become very large, and it may easily will much greater than the PEP that the government allow. Yeah, that's why you have to measure your frequency from time to time, or you make a very you have to test your equipment before you do the communication. Yeah. And these are some magic numbers. You see that 7, 14, 20 are some magic numbers. You see that most of them are 20, 14, 7, and 26.
So that equivalent to 5 volt.
Yes,
25
547
and
volts.
100.
26 is 100, as I remember. But we will go through the calculations later time, but not today. I guess I bring my calculator today, so just let me check. 26 PE, 26 is 10 to the power 2.6. Yes, 10 to the power 2.6, which is 300 and 400 watts. 400 watts. 26 PEP. 26 dB watts is 400 watts.
And 20 is 1.
Yes, and 20 is 10 to the power 2. Yeah. So if you are really good at math, you can calculate it immediately. The conversion between dB watts and watt is 10 to the power dB watts divided by 10. Which is mean is if it is a number 20 here, right? The power in watts will be 10 to the power 2. 20 divided by 10 is 2, right? 10 to the power 2. And for 26 here, it will be 10 to the power 2.6. Never mind, you didn't see the formula, you will be very, it sounds a bit ambiguous.
But they always ask you in dB watt, right? Not in
yes,
watts.
yes. But, yes. The reason why they ask you in dB watt is in the regulation of OFCA for the logbook, they will ask you to record the watts as dB watts, the power as dB watts, but not watts. But most of the people, they just record it by watts. But you can do the conversion and know what is the exact power you are using.
So dB stands for decibel.
Yeah, decibel. Yes.
Decibel watt.
Decibel watts. Yeah, which is changing from linear to logarithm. Yeah. Because the numbers will grow very big, so using a logarithm will make it easier to know what is the size of the number. You don't want to see significant numbers, right? The 10 to the power, a bunch of numbers. So you decide to use another scale.
Zero.
Yes, that's why they change it to the decibel. Decibel watts. We will go through the conversion from watts to decibel watts and voltage to decibel voltage. I don't know which lesson, but not these 2 lessons.
Question.
Yes?
I forgot my physics. My baby physics.
Ah, never mind.
What's the purpose of a carrier wave?
Oh, the carrier wave is okay.
Carry something.
Yes, to carry something. In fact, our voice cannot be transferred to very long distance, right? Our voice is just 20 to the frequency we can hear is 20 to 2000 hertz, which is very the frequency is very low compared to the wave we use. So for a shorter, for higher frequency, I will put it this way: the higher frequency can transfer the wave to a much farther distance, like 50 km far, for 5 watts to 10 watts. So you can make your signal to transfer to a very far away place, so that other people, when they receive your signal, they can decode it and know what you are saying.
Can I try explain this way?
Yeah.
Care wave is like a train.
Yes.
Empty
Yes.
train.
Yeah.
Is your vehicle.
Yeah.
And the message is a passenger.
Yeah.
If you want to, and carrier wave is radio frequency, the one we talk about, like 144 megahertz. It's a train, but just to deliver the train is no use, because we deliver no passenger, no goods. Right? So you put the passenger on the carrier wave, which is your voice message, and the carrier wave is the train transmit using the radio technology, the 144 megahertz carrier wave, and your message is a passenger, and they use something to mix with the carrier wave, so that at the other end you remove the carrier wave, and all you leave left with you is your passenger, which is your message.
The analogy, I understand. But
The physics behind, right?
so you have to have a train, right? in all the messages.
The train is your frequency, which is your 144 megahertz.
You have to create the train. Otherwise,
you have to create the
cannot
train
send
using
the
the box.
message across.
You have to have a signal generator to build the train. And when you talk, your voice is mixed with your carrier wave with the train.
It's later deducted.
And then because your train is radio frequency, it transmit through your antenna to the
So
atmosphere.
the interpretation is that you need a train to carry the message, otherwise the message cannot go.
That's right. And on the other hand, on the receiver, you remove the train from what I call filter, right? So something like that.
Okay, so
And then
Amplifier?
all's left is your message
Yes.
when you remove it.
yes. Now let's go a little deeper. Why do you need the train?
Because you need radio frequency to transmit, right?
I will use DX as an example. Okay, DX, which is we send a signal to a very, very far place. Like if I want to send a signal to America, I can't just shout out and other people will hear me, right? The signal will decay
Okay.
in a very quick way. But if you use some other frequencies that you decided, like we use HF, I will show you the HF later time if I remember.
The high frequency, yeah.
Yes, and other frequency, it can bounce and diffract from the atmosphere.
Okay.
So that your signal can travel a very long
So
distance.
the HS is your train.
Yes,
That's the
HS
carrier
is your
wave.
train.
And you embed your message in the
Yes.
high frequency. So it goes.
Yes.
Together with the
Yes.
carrier wave.
And different carrier, the different frequencies have a different decay curve. I will put it this way.
Yeah.
Sometimes they go through the ground wave, and sometimes
Yeah,
they
that
they
part I
are
remember.
yeah. That's
But I
why,
thought low frequency can travel further.
but they use in the water. The,
Yeah, in water.
Lower
I'm not
frequency.
sure why, but
Depends on the
Medium.
the ionosphere.
Yeah,
You know
ionosphere, yeah.
the thickness or which layer, like K or
yes. But I guess the low frequency
something like
just limited to
that.
the audible frequency, but not limited to.
You're talking about a lower
Yeah.
RF, right?
Yeah.
Lower radio frequency. It depends.
Does it
Depends
go
on the
further?
ionosphere.
Yeah.
Sometimes the
Because
lower
we use
the lower frequency will go around mountains, all this.
Yeah, yeah.
Right?
That's
If
what I thought.
it's a high frequency like UHF, it just
It just-
bounce back.
Bounce back, yes.
Yeah.
Bounce back.
we use different technologies to deal with different environments.
Okay.
Yeah.
Alright, next.
But just
Thank you.
from our experience, why we use that kind of technology.
I'm asking on his behalf.
Yeah. Really? Oh, I guess when we go to the hands-on, you will know why. You can try and know why. Okay. How to memorize it? 330 is a magic number. 330, this one is a magic number.
It's 430.
430, yeah. Or the 1146 is a magic number. So you know if 126 to 146, mainly they are primary. But 430 to 81,000
Secondary.
is secondary. Mainly both are
And
secondary.
there's nothing between 146 and 430.
Nothing, yeah. The bank
It's
is
not
not,
allowed.
yeah, not allowed it. And the business frequency for business use is not included here. So you know, hey, why the FM radio and AM radio is not included here? Or the air band, or we say the television is not included here. The television uses around 800 megahertz, which lies here, and you see it is not included in our license. Very important. So, because sometimes in the questions they will really trick you and put an FM frequency here and ask, hey, is this frequency can be used? And of course it says no. If you know the frequency is already being occupied.
What do you mean FM frequency not being
Um,
used? Somebody's using it.
Yes, like the RTHK, right?
It's not for you to use.
Yes, not for us to
It's
use.
a ham frequency.
Yes, this is a ham frequency, but this is already registered for FM radio
Okay.
for business, for really the radio.
Broadcast.
Yeah, broadcast. Yeah, broadcasting. Yeah. Very important. And frequency allocation. I guess I have go through it last time. Primary is dedicated for ham, and secondary is not. So if you are being interfered in the secondary frequency band, you are not going to complain to OFCA and saying that, hey, others are jamming my frequency, can you go out and help me? No. But primarily, yes, if there are someone share the frequency, or you are already using on this frequency and someone's trying to interfere your signal, then you can complain to OFCA. Yeah. Class of emission. Just a minute. Okay. So you will see that we've got a class of emission permitted here, right? Morse, telephony, RTTY, data facsimile, which is fax, SSTV, these 6 categories. Actually 8, because you see that television and pulses, there are 8 in total. Okay, so I'll explain to you what is the class of emission. CW, continuous wave, which returns the wave into 1 and 0, which is Morse. Like if you press a button longer, then it becomes a dash, and this one. If you press a button very short for a very short time, it becomes a dot. Beep. Yeah. So this is Morse code and how it is related to CW, the continuous wave. Yeah. We just make use of the carrier wave, just on and off, and we don't have to put our message wave to the carrier wave. Okay? We just turn it on and off. Digital, right? 1 and 0. So you know the binary stuff. Okay? Telephony, which is using voice, using our own voice. So when you speak through the radio using this machine, then you are emitting in telephony. Okay, so you know these characters, right? But what does it mean by these characters? I will explain to you later time. Actually, it looks like this. For frequency, for the modulation, which is the signal which you are going to transmit, it actually consists of alphabets, number alphabet. So we are talking about E at the very back. I will go back to this one first. And television in F. And you have to note that ITU recommendation is not exactly the same as OFCA allowed it. Okay, ITU recommended for all television you have to transmit it above 1 gigahertz, but OFCA limited you to use it above 5725 megahertz. Okay, so you have to follow OFCA, but not ITU. Okay, follow OFCA. Because OFCA put it here just for your reference, saying that, oh, this is the recommendation of ITU, but we modified it. So you have to always follow OFCA, not ITU. Television, 5725, okay, or 5.275 gigahertz. So bear in mind that no 1 gigahertz. You can cross it out in your notes. Why I put it here is because I have to use the exact wordings in your license. Okay? And RTTY, radio telegraph. This is the automatic Morse. So we are using a machine to type the Morse for you. Auto Morse code. This is written in B. Okay? Data written in D. And data can include different in different forms, as long as it is transferred in packet or like it is transferred in just other type that you can think of, but I can't think of here. So it is data is D, fax is C, SSTV is F. So what is SSTV? SSTV is you put your signal, you encode your signal into voice. Okay, just like fax, you are encoding your message or the photos, the photos into voice, and you transmit the voice through the radio. Okay, So you try to receive it, you can see beep 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 beep, that kind of stuff, that kind of sound for slow scan TV.
What is slow scan TV?
Very slow, cause you
several minutes for one
Yes.
frame, which is like this
Oh.
size.
not 1 FPS but one
Line by
frame
line.
per minute.
Line by line.
Line by
It
line,
shows
and
picture line
it
by
sounds
line
like
by
a
line
fax.
by line.
Sounds
Looks
like a
looks
fax.
like fax.
Only you and I know what is fax.
I know fax.
You know
Yeah, I
fax?
know fax. I'm born in that
Huh?
that kind of period, that period of time. So I know what is fax.
Now, I actually saw a slow scan.
Yes, very
So
slow.
sensitive. So SSTV is does not have to follow the limitation of 5725 megahertz. You can use SSTV in any ham band. Okay. Ham, HAM, ham. Oh, we say that this frequency that is allowed for amateur radio is ham. So we call them ham band in other words.
Handbag.
HAM, B-A-N-D, ham band.
Band.
Yeah, band.
Handbag.
Ham band. The frequency band. This word here. Ham band. Okay. Yeah. So just another words referring to the frequency allowed to be
So
used by amateur
SSTV
radio.
can use any of these.
Yes.
But
Yes.
just TV need to be 5
Yes.
25.
Yes. And
Up
use.
and above.
Yes. Yes, exactly. So you look at SSTV is F, but television is F. Though they are also F, but actually they use SSTV can be used in all the bands. Okay, in all the bands. Yes. This one okay. You have to remember what is A, voice is E, television is F, auto radio teleprint, which is automated Morse code, is B, data is D, fax is C, that kind of stuff. You have to remember. Yes. Okay, and we have two more types. If you combine the use of the class here, which is Morse and like data and fax together, maybe, or television and fax together, you have to use W, which is a mix of two class. Okay, a mix of two class is W, and pulse is P. And once again, ITU suggests it can be used for above 1 gigahertz, but you have to follow the regulations of OFCA, which is 5.725 gigahertz or 5,725 megahertz. Okay. So if you don't attend the lessons, you will be trapped by this PowerPoint. That's why you have to attend my class, right? Oh, actually, I put it here, but if you listen to me, then you know that 5725 is the only answer. Okay, for SST, for television and pulse, you will see that excluding SSTV. SSTV can use all the bands. Okay. Because we are using the radio in Hong Kong, you will have to follow the ASL and the regulation of OFCA in Hong Kong. But in other countries, you will have to follow their regulations. Yeah. But ITU just give you a baseline of what you have to follow, and other countries may have different adjustment on their baseline. Okay. They have different materials add on beyond the baseline. I'll put it this way. They take ITU as the baseline. Okay, so we have talked about the radio emission. You will see when they are transmitting the signal. Oh, maybe I should take a QSL card as an example. Oh, yeah. Thanks, Michael. Before he takes the QSL card, because when you write down the QSL card to others, you have to write down which emission class you are using. So we will use this kind of abbreviation when you write down the card. CW, this is CW, AR. Are there any冇喎 SSB 算啦 SSB 都得嘅呢個都係嘅都冇所謂 but it's better to you see these are for example but you can see that they will put down the mode of use, like here, SSB. Oh, you can pass it around. And we got CW here. Oh, maybe I can pass it this way. You can see the CW.
CW is A2A or something.
A1A, yeah. And SSB should be A3E. SSB is just the same as A3E. The first letter, so I was use F3E as an example, explaining why. F stands for FM, so which is the daily FM radio you are not listening to FM radio, right? Nowadays, no people listen to FM radio broadcasting. Yeah. When I was really small, I turned on the radio every morning.
Every morning.
Yeah, I listen on HTV.
Your car.
The car.
Of course.
Yes. So the F stands for FM. Okay. 3 stands for analog. So we have digital and analog. 3 stands for analog. And the last letter E is the emission class that we have just mentioned. E means voice, telephone. Yeah.
Why you say FM, but you say
Because
this is a normal?
This is FM.
Yeah, FM. But do we normally use FM on?
Yes, we use.
Yeah.
We can
Yeah,
choose to use. But I guess for most of the time they will choose use
it's
AM first.
right?
Yes, most of them are AM. But you can ask the people and see if they want to choose the FM. Because FM will provide a higher quality of voice. And it is much harder to transmit in FM. This is a bit harder, I guess. Harder to do in FM rather than in AM. So that's why they always use AM, SSB first. Yeah. SSB, I guess, is not A. It should be the other character, I forgot. Because AM means DSP, double sideband. Okay. CW, I've just mentioned. The first A means AM. No. You just use the carrier wave. No subcarrier. No voice is involved. You just use the carrier wave on and off. And the last A is oral telegraph, intended to, which is Morse. Okay. In short, Morse. You don't have to know the exact definition of the A. You just Morse. Okay. So if it is not intended to decode by ear, but decoded by your machine, which is become B.
So it will be A1B.
Yeah, A1B is you use an automated
machine.
Yeah. So you see that which is keying the carrier directly, which is doing the more stuff. Yeah, this one. Let me see if I mentioned the. Oh, good. I haven't put down the decibel calculation. Okay. Maximum power. You will see that. It is a special condition for 144 to 146, and this one. Okay, 144 to 146 is always 14 dBW ERP. So I will explain what is ERP later time. ERP. Let me go through this one first. Just a minute. Let me have a check. And for portable, I've just mentioned it is 7 dB watts. So you can go to your Annex B1, which is the license, and refer to here. You see it, they put a star here, which is important.
If there's no brackets, like,
Yeah.
can we go back to the previous page? The one,
This one?
it's, let's say 21 megahertz,
Yes.
right? It's a 20.
It's 20.
If there's no brackets, no 7/14,
Yeah.
does it mean we can bring our unit out and use it as a mobile unit with 20 dB watt, or still apply?
It
that
still
in-
applies. You can bring your mobile. Mobile means the car, the radio.
Yeah, whatever I bring
whatever
out
you can- yes.
or handheld, whatever.
Portable is different from mobile.
Yes.
But
mobile, yes.
Doesn't have a bracket, right? Like the other one, like 144 to 146, they have a bracket.
The bracket is for portable.
For mobile, the car one, I guess is yes. As they didn't mention, the portable means
14 is for mobile and 14/7
Yeah.
is
If it is not
then this one
mentioned there,
20.
can I bring out a unit to open area and use it
as a
with
mobile.
20 dB watt?
Well, I think this class only applies to a fixed station. So if you are using a portable machine, then you fall
That
into
means I
category.
cannot have a portable
No.
unit.
You cannot have a
with
portable.
even like 7 unit, 7 dB watt. I cannot use.
You can use the same machine but transmit less than 20.
But it doesn't have a bracket. So if I follow this schedule, that means I have to use my 21 megahertz transmitter as a fixed station only.
Yes. Or if you bring it
Thank
out,
you.
you
Actually-
have to tune it down.
Because if
It-
looking at
down.
looking at the table, it doesn't allow
Yes.
me to take it out.
Yes.
Right?
Let's see if I got more information here. Because I really question. This is a good question. Because when I go through the materials here, I see that there is one line saying that if you are using 30 megahertz or below, you have to write down the logbook, right? That kind of line. So I guess they didn't make this limitation. But I guess it's better to ask OFC first. Yeah, to clarify first. From this table, we didn't see that it is limited. But I don't know how OFC thinks. Yeah. Because sometimes, I don't know.
Do you have the legend for the star? Do you have
I guess,
the full page?
yes.
What's the wording?
You can see. I will change it into English. Oh yeah, I don't have to change it in English. It is already
Bilingual.
bilingual. Yeah, bilingual. Everyone is bilingual. So you see that it
So you
is
just say 20.
yes, and see note 3, right? So we will go to note 3 directly.
For mobile operation, the frequency band to that frequency band is 14 dB watt.
Yes.
For portable operation is 7. So it doesn't mention
Yes,
like
other than this
21
band.
megahertz, the other
Yes.
frequency.
So from the wordings of PK's, if it is not mentioned, then you can play with it.
if this is the case, I can bring out
Yes.
my fixation into the open area and transmit 20 dB watt, right?
To my understanding, it is yes. Yeah, because I really seeing other people playing that kind of stuff.
But whether it's practical or not is the other
Yes.
topic. But
They really put that.
legally, I can do this.
Yeah.
Right? I can transmit 20 dB with the maximum power.
Yes. According to this one. So actually, there are really people bring all their antennas and bring their mobile station to Cyclone and
Yeah.
do the communications.
Okay.
Yeah. So if they didn't mention, so you know, just follow the numbers here. Yeah. But it is practical. So saying that, are there any mobile devices? I would say portable devices that allow you to use the band here,
Yeah.
which is another question.
Yeah. Yeah. I have 2 already.
Oh, really?
Yeah, about that size.
Oh.
And
Okay.
battery power. So you can, of course, the machine itself cannot transmit 20 dB, but you can always put an amplifier to
Oh. Yeah. So let's go back to our notes. Blah 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 blah. Easy. Yeah, go for this one. Okay. And okay. So the we see 2 different words here, right? The first word is EIRP, and the second word is the first word is PEP, EIRP. So I will explain these 2 words first before we go to the modulation because it's important. Okay, you know that another band which is for very low frequency, 5.35 to blah 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 5.3665, you can only use 11.76 dB watts EIRP. Okay, so ERP is different from EIRP. You will see that in your license. Okay, so ERP is the actual power you transmitted. You have to also take in account to your gain on your system, which is your antenna or your amplifier, which is the station here. So sometimes when you emit the signals like 5 dB watts, 7 dB watts, but sometimes this is just your output. You haven't calculated your antenna if they have this is not isotropical, which is like a donut shape, but they have direction, like they are pointing to some directions. So we said that this kind of antenna is having a gain, which is like Yankee antenna or dipole antenna. They also have gain. Okay. So you see here, transmission line loss, blah 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 blah. The most important word is antenna gain here, but I don't think they will ask you that details in your license. But you know that what is the difference between ERP and EIRP if they really ask you about that. The difference is just about having the system gain, the antenna gain here. The difference is here. Okay. So for most of the antenna we are referring is a dipole antenna, which is like two metals like a T shape kind of stuff. But in theory, what we are referring is a donut, an isotropic antenna, which is like a donut shape. So, so to compensate the difference, we always say that 0 dB is equals to 0 dB referring to a dipole antenna is equals to 2.15 dBi, which referring to the difference between two kinds of antenna. Okay. If we didn't mention about dBi, we are always mentioning, we are referring to the power of a dipole antenna, DIPOLE, dipole antenna. Okay, but if we really add in the word I, we are referring to the isotropic antenna, which is two kinds of antenna. You will see that here. The half dipole blah, 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 have a 2.15 dB compared to an isotropic radiator. So did I give you the diagram? Isotropic. So the isotropic radiator is this one. You will see that this half diagram when you talk about the Wi-Fi signal, right? The donut shape, the radiation. But for dipole antenna, their signal is not like this.
It's polarized.
Yeah. Yes, this polarized. They are talking about this one. So the dipole antenna have a 2.15 dB gain.
So
Yeah.
ERP is always better than EIRP.
I guess it is the two different measure system, but they just ask you if your antenna have gain already. Like sometimes if you are using a Yagi instead of a dipole antenna, then your gain will be different. It will have a higher gain, much more higher gain, right? But if you are using dipole antenna or just an isotropic radiator, then you have a lower gain. The difference is what the gain you're referring to, okay? Or just minus 2.15. If it is you are using the ERP measuring the half the dipole antenna,
If I'm using something else, not a dipole and
Yeah.
not an isotropic antenna, how am I going to do that?
You have to know your gain first.
And the effective power would be called ERP as well, or something else?
ERP. They will just measure the final
Okay.
result. Yeah. So So that's why you have to measure
So
your
ERP is the end result. And
Yes.
EIRP is theoretical.
yes using isotropic radiator. Yeah, you can see we can say in this way. Okay, and one more stuff to talk about. Oh, how come I missed my slide? But never mind. There is one line saying that the band you are using should cover more than 99% of your signal strength, the emission power. The outband emission should take less than 1%. Okay, so if sometimes your signal is not very accurate, you may interfere in others. And that kind of outband emissions, both sides and including a pesticides, should be less than 1% of your total emission power, which is 2.5 SD if you know the if you know that what happens, I forgot the term, but you know what is the SD, right?
Standard
Yeah,
deviation.
the standard deviation and 统计 is what?
Statistics.
Yeah, you know the statistics, then you know what 2.5 SD means. So you have the number in your mind. 1% outband, including all the outband emission and pesticides. Because sometimes if you are using that 144 megahertz, you may have a harmonics of 288, that kind of harmonics. This also counts. Or if you are using a very wide band, you should cover it at most 144. You are going to emit your signal at 144 megahertz, but your signal covers from 139 to 150, like these numbers. Then you are using a very wide band. You have to make sure, saying that your equipment is not that good, so you have to be aware of the outband emission. Radio hazardous, we have to cover the radio hazardous. Very important. Just memorize this number. Actually, we can explain why. You will see that 1 to 10, it is the equal strength should be 87 over square root f. F is just here. You don't have to take in account the megahertz. Just if it is 1 megahertz, then just 1. 10 megahertz, just 10. Okay. 87 divided by 10, square root 10, which is 3 point something, right? 3 point something. Okay. And 100 and 400 to 400, 10 to 400 megahertz, 28, fixed number, and the equivalent plane of power density. So, because sometimes we can think in this way: the radiation, and just like a sphere, right? They're expanding through a sphere. So the power density over the sphere should be less than or equal to 2 watts per meter square. Okay, so you are not going to expose this number, okay, for average over 6 minutes. Okay, and blah blah blah, 1.75 square root f. You have to really memorize these numbers, because if it doesn't appear in my exam, it will be likely to appear in your exam. That's why remember it. So you see, because there are not much things asked in the ASL. So
But they ask you the formula, or they ask
Yeah.
you to calculate the value?
I don't know. I really don't know. But calculation does not make it's not that difficult if you know the math behind. Just doing substitution, and you can. So that's why bring a calculator with you. And so you see that it is actually like a U shape, right? The frequency here, the equal strength you can is allowed to expose is much lesser than the very high frequency and the lower frequency. Looks like a U shape if you really make the calculation. These are the metric numbers. Memorize them. Really. Okay. For pulse, you are not going to exceed 1,000 times the specified limit. given the frequency, blah, 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 blah. And the limit itself is not exceeded average over a period of 6 minutes. So I will interpret in this way. This frequency, you are not exposing to the radio frequency all the time, right? Sometimes when you are not speaking to others or receiving the signals, you are not going to exposed to the radiation. But if you are going to, so you can exceed the numbers for a short period of time, but you have to measure it in a 6 minutes average. If it's average out and lower than these numbers, it will be fine. But if the average out number is much higher than this one, then it will have a potential hazardous to you. Okay, and for the pulse, for every time the signal emitted, it is never 1,000 times this effective strength number. Like if you are using the like 400 megahertz, it is a fixed a constant number, so it makes the calculation easy.
Pulse of 400.
Yes, but it is a radio hazardous.
5725.
Yeah. 5725 is here, right?
Yeah.
61. So I will use 61. Because you are not allowed to use, but you can't regulate others not to use this one. We don't know. It's sometimes it's not maybe not a handband, right? Maybe other devices. Okay. So to make less confusion, I'll use 61 as an demo. Good number, right? 61 constant. Okay. For pulse, which is 300,000 megahertz, 61. So your one time, the pulse per time should not exceed 61,000 volts per meter. The effusion should be less than 61,000 per pulse. And the pulse should also be averaged out in 6 minutes and to see if it exceeds 61. Does it make sense? Two criteria. Single pulse, 61 times 1,000. No exceed this number. And for all others, including pulse and all the emission class, you are not going to have this 61 volts per meter more than 6 minutes. Should I be taking it this way? Average out number. Average out number. No, I shouldn't say it this way. Yeah, just this number, you have to count it for 6 minutes. And does it exist, the 61? Yeah, I will say it this way.
I think the
This one?
the regulation is talking about the second.
Oh, yeah. Sorry, I'm sorry. About this one, yeah, the power density. Because the time when I studied this, I just memorized the 1,000 time pulse and the 6 minutes average out number. This column. Here. Okay. This meters and watts per meters square, which is a surface area, right? 10 times 1,000, which is 10,000. Per pulse, no exceed 10,000, and per 6 minutes, no exceed 10. Okay? Yeah. And there is one more weird regulations in Hong Kong. If you use your, you are not allowed to use 30 megahertz band near the filling station. Okay. The reason why is in the past, 30 megahertz can be emitted through a very large power. Yeah.
Because of spark.
Yes, and it may cause sparks if you are using a very large emission power. So that's why they forbidden this kind of emission. Actually, there is one more regulation. If you are using 30 megahertz, you have to always log the logbook. Because 30 megahertz or below, you can use it as an HF. You can communicate with others through a very long distance, cross country. So they are afraid of you saying that they are inappropriate words. So you have to always lock your logbook, even though you are using a portable radio station below 30 megahertz. Call sign, no one follow this one, but it is written in your ASL. /P, so take myself as an example. My call sign is VR2 URL, right? So I should make a call. I should name my call sign as, if I'm using a portable station, which is a handheld radio, I should name myself VR2 URL /P. P stands for portable. And if I'm using /M, which is a mobile operation, which is the radio station on your car, /M, okay? And /MM, maritime mobile, which is the watercraft, okay? So for a fixed station, you don't have to add any slash behind. /P, portable, handheld. /M, mobile, for car. /MM, watercraft, okay? But if you are asking me, are there anyone really adding the /P when you call the radio? No, no one follow this one. Impractical. Okay, and you should also name your call sign at the beginning and at the end of your call. If your communications exceed 15 minutes, you should also name your call sign per 15 minutes. Okay, per 15 minutes. Not important. If they are saying that if you are using the call sign, use C first. Okay. PK should always use himself as an example. Your call sign should be well-known words and should not be factitious, right? Or objectable characters. Because his call sign is PK, and you will think of another words in Cantonese, some vowel language in Cantonese, right? So he is always making jokes of himself. But no, it doesn't matter. Just because sometimes we are using the alphabets or NATO phonetics symbol, right? You can change. Sometimes you can change your call sign a bit. Like if there are someone saying that A, the alphabet A, the character A. Most of us will say alpha, right? But for the American guys, they can say America. So as long as the other people understand which letter you are referring to, you can use that word. You don't have to always follow the NATO phonetic symbols. In practical world, but in your exam, you have to follow the NATO phonetic symbols. Okay. And the second line is, if you are sending messages through Morse or through other kind of method, like images, you have to make sure your call sign is printed on it clearly. Can be identified. We are not always using voice as a medium. We can use images or Morse code, or even TV, right? So you have to make sure your call sign is printed on the television clearly. Okay. Record, date of transmission, UTC time, frequency band, class of emission, power, and the call sign, yourself and others. You have to remember this one. There is 2 points to note. The time is always in UTC. UTC, okay? Not HK, not Hong Kong time, but UTC. And the power should be noted in dB watt. So in Annex A1, they didn't mention about it, but in your Annex A4, the explanation, and Annex C, they give the details out. So beware of it. Yes, and below 30 Hertz, if you are using a mobile or portable operation, you do not have to look down the record on your logbook. But if the operation exceeds 30 megahertz, always logbook. Okay, always logbook for below 30 megahertz, regardless of which device you are using. And blah blah, regardless of how hard copy, so that the OFCA guys can check your record easily, hard copy. So if you come out station time, you will see a lot of logbooks over here in the radio room, and the logbook should be kept as long as possible, but at least you should keep it for 6 months. 6 months, magic number. I don't want to talk about this. It's very tiring. If there are any issues that you are changing your devices, or you change your address, you should tell OFCA within 72 hours for such a change. Quantity, the make, model, and serial number. You have to also tell OFCA. But if your devices can be purchased in Hong Kong, OFCA have already tested the device for you. So you can just tell them your model number and serial number, and they can issue the disk for you. We call it the emission disk. So that the label you stick on the devices, we call them a disk. Okay. Okay. So we can take a deep breath first. We are still going to talk about. Oh, maybe I can talk about the NXP4 first, because it is very short. I can finish it within 10 minutes. You can refer to the details here. You can click it, okay. But I'll just go through the main points. For point 4, if you have changed your address or are there any amendments on your license, you should always send your original copy and duplicate license. All of them, all the licenses that issued by OFCA, you should always send them back. Because this is the property of the government. If you lost it, if you need to make any changes, just send them back to OFCA. They will reissue the license for you. Okay. Okay. If you don't send them back, they can charge you a fine or send you to the jail. Okay. If for any mobile station or handheld station, you can apply for. Let me see. Yeah. Nothing changed. Yes. Additional change. If you have a new radio station on car, just tell OFCA and send all the materials back to them. They will help you to give you the new license to you. And always remember that they didn't mention it in B1, but in B4, your mobile station can only be installed on a private vehicle. You are not allowed to install your mobile radio on any other places. For car, only private vehicles for car. Okay, and if you have new radio equipment, once again, tell OFCA in 72 hours. 72 hours is a magic number. If you have many changes on your addresses, on your devices, on your numbers of equipments, always tell OFCA within 72 hours. Okay, and sometimes we have to put our duplicate license on different places. Like for a fixed station or for watercrafts, you will have to apply for a duplicated license for $55. It is a must. Otherwise, you're violating the regulations. Okay, $55. Additional fixed locations, vessels, or watercrafts, you will have to apply for a duplicate license. Okay?
So you keep the original at home, and this duplicate
Yes.
with you in the car.
Yes, or in a fixed station, because it is more often
Or if
on
you
the
have a second
watercraft.
home, then
Yeah. For second home, I have to explain it because Michael gave me the details already. Yeah. Okay. If you are applying for a radio station, in the vessels, for car, you don't have to apply for duplicate license. Just fixed location, watercrafts. Okay.
oh, okay.
Mobile is you don't have to do it because you have to stick your identification disc or just the label. We call it the label, okay? But in the formal wordings, it is identification discs. You have to stick it on your 擋風玻璃 on the front glass, windscreen, windscreen, okay, on your windscreen. And the application for this identification disc is free of charge. Just apply it for portable and vehicles. Okay. And if you have lost your or damaged your identification disc, just go to and apply one extra one. You are not going to pay for it. Okay. And point 11, the publishing of licensee's name and address. Okay, I really sent an email to OFCA, and the answer is saying that we don't know we have a system like this. And I just sent my email 2 days ago. And so beware that you have 1 month time for you to send to OFCA saying that I don't want OFCA to publish my address and name due to privacy reasons. Oh, actually, you don't have to tell them the reasons. Just saying that, oh, I just want to hide my name within 1 month time. So if they really ask you these questions, you know that there are some numbers about the time, like the privacy, the changes, and to giving them the copy, the license copy, which is 72 hours, 1 month, and 4 weeks time. So you have to remember these 3 magic numbers. If they really appears in your exam, it is very likely to be free of one of the 3 choice. Okay, 72 hours, 1 month, and 4 weeks. Duplication this is free of charge, but the duplicate license is $55. Okay. If you don't want to continue for license, you have to send all the identification disc, the label stick on your car or on your handheld radio, your duplicated license or the original copy of your license within 4 weeks time. Okay, before it expires or revoked. Even you want to apply for a new license as it is damaged, you have to tell OFCA. Okay. Otherwise, you fine for $10,000. Okay. You should also return the damaged license or identification disc to OFCA. So to prevent others using your information. Okay, and the license in good status can help others to identify you. So this is just like an ID card. If you're not bringing your ID card when you're going outside, you'll be in trouble, right? This is just the same. Okay, extra stuff. So if you have an extra home, you want to set up an extra license, you can go to the website here and search this one, addition for fixed station license location. Then OFCA will help you. Okay. Okay, and aircraft. I didn't search I searched in the web and I didn't find any information for satellites. But for aircraft, you have to seek for application of, let me see, Hong Kong Civil Aviation Department and OFCA at the same time. So it is a different license if you are applying for the aircraft station license. The ham band, for ham and amateur radio, we are not going to use set up the radio station on aircraft, right? But if you are applying for the aircraft station license, you can do so. But you have to seek the authority from Hong Kong Civil Aviation Department, 民航處. Okay. Okay. So in this in the past lesson and this half of the lesson, we have just go through part 1 of our materials. this 1 to 1.5, which consists already 40% of your marks. Okay. The rest of our class will be easier, and we'll go through part 3 first. Part 3, which is the operation, procedures, and practice. Once again, which is about radio, but I have much more diagrams here, right? So it will be much more fun, I guess. Hopefully. But I think I cannot go through all the materials, so we'll leave part of the materials to the next lesson again. Okay? So why don't we have a 5 minutes breaks, right? If you want to go to the toilet, you can go to the playground over there. You can go out and have a walk.哇，乜全部出晒，見晒。可以出嚟睇喎，我哋有人喺出邊玩緊 radio。如果成架車，可以we have got demonstration, so you can try the application for other members if you want.
黐喺嗰個火箭度，即係佢火箭度話左腳打咁係左腳呢個。
過咗衛星就冇得睇。
係過咗衛星就冇得玩嘅，所以睇時間我哋。睇下陣間嗌唔嗌到啦，我哋嗌到就嗌啦，嗌到就睇人嗌咯。得飯啦，你幾點啊？8:24，OK。3個字，講3個字先。So we have we have a certain hands-on sections today, hands-on demonstration today. So we will go to see the demonstration at 8:40. Okay. The operation is easy actually. You don't have to memorize a lot of stuff, but it is highly related to safety. So it is more likely to related to your practical usage instead of the theory. I think this part only consists of less than 10 questions in your exam, but you have to know the details if you go to the practical. So it's less painful. You don't have to memorize all the stuff. Best practice for radio station communications. Proper installed equipment and antennas and adequate grounding. Okay, don't hurt yourself, right? That's why we have to install the equipment safely. And you don't want the voltage. You don't want to touch your high voltage. So you have to have adequate grounding. Sometimes the antenna is very pointy and they attract thunders. So that's why thunders. Yes, yes. What? If you are in thunderstorm, you have to remove your antenna and go back home. Otherwise, the thunders will strike you to your antenna. Yeah. Yes, this is how the 避雷針 works. 避雷針 is what? Thunder. Oh, forgot. Never mind. But you know the concepts. the potential difference is very little, right? The physics stuff. So we have physics guy here to explain why. And use filters and shieldings so that you don't want to interfere others. So that's why you have to filter your signals, or you already know your device will emit the petacytes or the harmonics. You have to shield your device so that this kind of not non-intended frequencies will not escape to the space. Test your equipment so that you make sure you are calling the radio on a correct frequency. Adjust the transmitters, tuning. You don't want to damage your radio station. If you have poor tuning on adjustment, we will mention the standing wave ratio (SWR) in later lessons, saying that if you cannot emit your signal properly, you have some powers will be returning back to your station. If the returning power is too large, then you damage your machine. Yeah, that's why we have to always make sure the tuning is correct. We have to make other equipment. Safety practice. Make sure that actions in one area that can affect. This one. If the place that you call radio, like in Taiwan, take my home as an example. I nearly cannot call the radio out. So it's not happy if you are not using the radio. You want to communicate with others, right? So you have to make sure your place is good and you can call the radio. Like HARTS is a very good place. We don't have mountains around or buildings around, not much buildings around, so that our signals can be easily transmitted to other places. Okay. Just bear in mind, you are not seeing this kind of words in your exam. It's just a rough concepts to you. Okay. Station layout. The station should look like this. You have your transmitter. It is just an example. It is not a must, but you have to make sure your transmitter. You have also other devices that can help you to measure your frequency, like the SWR meter, measuring your frequency or measuring your power you send out, and the return. SWR is measuring the returning power, the ratio between emitting and returning power. Okay, and you have to have a 24-hour clock here. Cause in our logbook we are looking in UTC time, so we need to have a clock knowing the exact UTC time at the moment. Okay, I don't see that in our radio room. It's just an example. Okay, transmitter and receiver, it may be two different devices, but we have some all-in-one device. And you see that there is a logbook here, so the logbook is important, and the stationery. Yes, and make sure your table is big enough so that you can put all the equipment on it. You don't want to have a very messy room, right? It's not convenient if you don't have your adequate space. Yes. This kind of information is provided by ARRL, which is our reference book that OFC suggests. The station, make sure it's personal safety. You are not going to put your wires or wires around so that you will be very messy, and when you need to escape in emergency, you trap yourself, right? If your station is really messy. Safety is important, and sometimes you may have visitors around, right? So that make sure your station is clean, and you don't want the visitors playing around with your equipment and it damage it. So you have to make sure about this. Lock the entrance. So sometimes we have a room here and we can lock it up. If we have some public events, we can lock the room and no one can enter the room if it is necessary. Okay. Small children. Children is a problem, right? We have sometimes we have some scouts visiting us, visiting camp. So make sure if the children comes, they are playing around, they can't go to the radio room directly. Okay, to make sure that. Wiring. Hey, just a minute. Let me correct my typo. Some main points. Put the fuse on. Okay, individual fuse for each equipment. So we have a very big circuit breaker with us, right? In every EMSD approved buildings, but for every devices here, like our sockets, should put a correct fuse in it, so that to protect your instrument, protect your equipment. Okay, 3 conductor power cords. I don't think it is necessary. I don't think it is common in Hong Kong, but you know that a grounding connection is important. And install station wiring in a high okay, so we have got a lot of wirings here, especially when you have to connect your devices between devices. You have a lot of wires, so make sure this wires is not that obvious and that people cannot touch easily. Okay, like take the antennas at the back as an example. We got a controller in our radio room to control the antennas, rotating and elevating. So make sure these kind of wires are connected and not that easy can be touched. Yeah. Earthing, we'll talk about earthing later time, so we are not going to talk about it. Easy disconnected for the equipment from power lines and antennas. Sometimes you like our antennas is put outside, so if there are any problems, we have to make sure take the outside as an example. So all the equipments here can be removed easily. So make sure if you really need to remove the equipments, your wiring it should be make you easier to pack all your setups. Okay. Okay. So we have talked about fuses, and we've got different fuses here. Most of them we can see is the cartridge fuse and automotive fuse. Automotive fuse is the fuse used on the cars. Okay. We are not going to use explosive fuse. Explosive fuse is for transmitting lines. Actually, we will use cartridge fuse and this one. And I will talk about this one, the cartridge fuse most of the time, if I'm referring to fuse. So fuse can help you for this kind of stuff. So does anyone, all of you know what is a fuse, right? It's a thin metal pieces. So when the current flow is too large, the metal piece will just blow out, will melt, so that the current will disconnect. Okay. So when the fuse piece, the metal piece melts, the current will break it. So we have different fuses limitations, like the 3A fuse and 5A fuse. And the larger the current is allowed to pass through, the metal piece will be thicker, okay, which allows more current to go through. So if you use the correct fuse, but the fuse still blown up, which means the current inside the equipment is much larger than the fuse can withstand. Like you are using a 5A fuse, but the 5A fuse blow up, which means the equipment here is probably having a 7A current, which is large enough to damage your equipment. So that's why we have a fuse. Yeah. This is an illustration of how the individual fuse should be used. You see that we have a large fuse here, right? And for each equipment, circuit A, circuit 1, 2, 3, we got a fuse in front of it. Okay, but in Hong Kong, we may not have a fuse, but we have a circuit breaker instead. Example of a blown fuse, if you have never seen it, but I guess all the people in Hong Kong should know what it is, right? Okay, fuse replacement. I will always suggest, there may be some tricky questions in your exam, but always replace the blown fuse with the same rating. If it is a 5A, replace with a 5A. You should not make it use a 10A fuse to replace for the 5A, or use a 3A to replace for 5A. Okay. If you are using a higher rating, which allows more current to pass through your equipment, which will cause damage if your equipment is really malfunctioning, further damage, or even on fire, right? But if you are using a much lower rating, like your equipment should have a 3A current running with it, but you use a 1A fuse, then your equipment will not be working. Your fuse will always blow up. Okay, you may want unwanted interruption. But if you really don't have a proper fuse with you, you should always choose a lower rating. Like if your equipment is using a 5A fuse, you can sometimes in practical, okay, try to use a 3A fuse to replace it. Okay, you cannot replace it with a 10A fuse, but you can try to use a lower rating. Okay, I make it very clear. Okay. Circuit breaker. A circuit breaker looks like this. So very recently, I know how it works. Finally, it's all due to magnetics. Okay, I'm not going to explain very deep in it, but if a current run through a miniature MCB, the circuit breaker we are always referring is a miniature circuit breaker, MCB. Okay, look, compared to an MCB, we got a very large circuit breaker, like for a transmission line or a step down station. Okay, that kind of circuit breaker is much a larger scale and different from this one. This one is just a smaller one. Each should be a size like a mouse, right? This one. Yeah, you know that it is very small, the circuit breaker in your home. And if there is a different ratings for MCB, so like it's 13A in daily usage. So if a current more than 13A is run through the circuit breaker, the magnets here will generate a very large magnetic force to attract the metal piece here to combine with it. So the circuit will break, okay, and the connection breaks. This is how the circuit breaker works. Using a very large current to generate a magnetic field to attract the bright line here. The bright line here. Okay. Okay. Very important. If you live in Hong Kong, you must know what this is, right? A free conductor power cord. Earthing, live wire, and neutral wire. So you should have different fields here. Okay. So we'll have a quick pause here. We'll go outside and see our antenna. Let's go. 佢要撳一撳咧，然後再開嘅，好似拉嚟先。So we see if the antenna works. Can they communicate with each other? 不過應該 OK 嘅。
有時你帶隊人哋走堂啦，係咯，繼續錄緊添㗎，你自己翻去 cut 啦，
梗係自己 cut 啦，
你自己翻去 cut 啦。
上次不過都冇 cut 到，
唔係嘛？不過你一 cut 兩個好難升翻嚟，咁麻煩。
嗰啲舊嘢咩？個 SWR meter。
唔係呢個係power
電啊，佢由呢個 AC
呢個 power supply
呢個咧？
呢個都係 power supply。 咁啊 supply 我唔知點解佢有兩個，但係上邊嗰個先係 radio 嚟嘅。
哦，就主要下邊嗰個。
咁呢條就係一條傳説中嘅 transmission line 咯。
傳説中。
傳説中。
我
我有時都唔知呢條係咩嚟。
50盎。
咁你見到後邊呢兩條紅色嘅先係嗰個 power supply line、transmission line、transfer 喎，係天線。因為你呢度見唔到條天線啊嘛，咁其實係駁咗去屋頂咯，我哋。
嗰條嘢。
哦，嗰度好多支其實你睇到
配啦，
係冇錯，50盎。我呢條線咧台底一路穿到嗰度，嗰度一穿到嗰度咧，呢條基本得就喺外邊嗰度入。
良好嘅 wiring 啊，咁樣唔係良好嘅 wiring，咁係坐唔食飯。
是但，有蚊香添。
係蚊香咯，喺度燒住。冇睇下邊，冇睇下邊，冇事。
越短越好啊嘛。
係越好嗰個但有時咪即係安全第一咯，都係話。
又唔可以距離夠太近喎。佢有自己關於自己。
哦，天線。So we have to talk about what is free conductor power cord. So the free conductor power cord is a power plug with three different lines: the earth, neutral, and live. So you have to know which colors is which line referring to. So the
好似 I think Hong Kong's changed their colour some years ago, right? Some white, black.
You're talking about 70s.
No, it's recently.
Yeah, I think recently.
Yeah,
Really?
I think I captured it.
really.
Yeah. So I'm not sure which
yeah.
system you're gonna ask.
If you have the information, just let me know. I will just keep on using this one first. If there are any updates, and I will talk about it in the next lesson. Okay. So the earth wire is green and yellow strips. So this is the most important, not most important one. This is the one for safety. So when anything happens, this line helps to ground your electricity, so to protect you from dangerous. Okay, so prevents any current flowing through your body. It will flow all the currents to the ground. Yeah. Neutral wire.
Before I just try on my luck, I changed it. I would notice the color. I just put it back into.
It might work.
It
The problem is
So
it might work.
every time it works.
It's still dangerous.
Very dangerous. The
Until
blue,
now.
actually, the earth wire is 0 voltage for ACs. So it is same as neutral wire. So in the past, there are some electrician saying that you can actually split the neutral wire into two and put it one to earth and one is neutral. This is actually very dangerous. Don't do that. Don't do that. 3 wires connect to 3 different places. Okay, don't split any wires. The 0 volts for neutral is different from 0 volts in earth. Okay, the 0 volts is neutral is acting as a anchor point. Should I say that? So that for comparison to a live wire, the live wire will flow from positive 200 positive 300 something. I remember. So you can calculate. Divide by square things. This is 311. Floating from positive 311 volts to negative 311 volts. Okay, so that's why you have 220 volts RMS, average. We'll talk about it in lesson 5. I'm drafting the notes right now for the RMS, the AC current. So the neutral wire creates a potential difference between live wire and neutral wire. Okay, the live wire is floating from positive to negative, and the neutral is always 0. Having a potential difference, the currents will flow. If there are no potential difference, the currents will not flow through the wires. Okay, and the earth is for protection, so that if there are any issues, all the electricity will go through the earth wire and really goes to the ground. Okay. I have an reference from EMSD, so that you are not going to that deep, but I will just put it here for your reference. Equal potential bondings. So that you have to connect all the places with 0 volts, 0 volts. Okay, so that's I don't know why, but you can connect to the main water pipes. There's the gas installation pipes and other pipes. So that you have this diagram. You have to connect all the places that have 0 volts. Actually, your house do that for you. You don't have to do it on your own. Yeah. They call this the equal potential. So that if there are any things occur, like there is a shorting, voltage shorting, this 0 volts place will create a very large surface, so that it can help you to earth the electricity. Okay. There is a physical reason why they have to do this, but I forgot. It should be about the inductance and capacitance stuff, but I really forgot about it. It's mentioned in the EMSD manual, but we are not going to go through it. Okay. So in the law of Hong Kong, bear in mind that you can only create an equal potential bonding for copper pipes. Okay, copper pipes. Aluminium or cooperated aluminium should not be used. Okay, bear in mind. But normally this part is not done by you, but done by your computer building, right? Just for your reference, so that you see that if any places have a short circuit, the voltage will run through all the pipes here and go to the main earth bar in the ground. Okay, this is how the equal potential works. But not all these pipes connected to the main earth bar separately. Okay, they are connected so that the 0 volts is lies along all the places. Okay, this is the physics reason why you have to create an equal potential bonding. But you are not going to do it in your exam, so I'm going to skip it. You can do your math if you are interested in it. You will see that actually if you do the equal potential bondings, the current flow through to the metal ground will be much less than the individual grounding. Okay. Yeah. The current flow to the ground. I should put it this way. If there is any fault in electricity, most of the electricity can flow through to the ground if you have a proper bonding. So you see that the current here is 128, which in fault, if there is any fault, most of the current will go to the ground. But here, if you have an improper grounding, you see that the total current run through to the ground is still very small compared to the proper grounding. Okay. So this is the reason why. And earthing terminal is different from the equal potential bonding. In Chinese, this is 等电位, that kind of words in Chinese. I should have included in my notes here. So if you're interested in it, you can go to here and have a look. And there are some notes in Hong Kong saying that the gas installation pipes should not be used, but I really dig into an EMSD manual. It said that gas station can be used. But there is one point to have bear in mind. For main water pipes, there may be some waters on it, like for the humidity reason. Condensation. Water may condense on the main water pipe. So you should have good insulation on your main water pipe to prevent it from condensing the water on the surface. Main earth terminal. Okay, so the main earth terminal is the final destination in your house, where the current will go to. So don't remove this line. If you this line, you know that the current will go through here. Finally, if you are in your house. Okay. So make sure your stuff is working well. There are some reference here, so that your wire should not be less than this surface area, right? But once again, not in exam. So you know that good earthing should be done. Okay. Yeah. If they really give you this one, just know that don't remove this line. Use copper and use copper as your earthing. Yeah. And earthing conductors. The earthing conductors is really the metal bar that buries in the ground. And it should always mix in copper. No aluminium should be used. Though aluminium is also a relatively good conductor, but no, under the law and regulations in Hong Kong, use copper as your earthing bar. Okay, safety. So make sure your good equipment is in a good condition. If you know that your equipment is already having faults, don't use it, and you have to have proper grounded. Sometimes you may have to ground your antenna separately. So we have a great antenna setting at the back. So for that antenna, we need to have a separate grounding for it. We should. So that's why we have some safety concerns here. Use appropriate fuels. I've just explained how fuels and circuit breaker use. So you have to use the same rating to prevent any faults. Proper and effective grounding system. Building an equal potential bonding to spread the electricity across. Use copper as earthing ground. Okay. So actually, this equal potential bonding is at the point of 0 volt. So if any fault, the electricity will first flow through the equal potential bondings, and then flow through the main earthing terminal, and finally go to the earthing conductor. Okay, this is how the grounding works in Hong Kong. And how should it work? Okay, and if you have a large capacitor in your devices, you have to discharge it to prevent you shocking yourself. And switch off the power. And sometimes there are some manuals saying that you should install a micro switch in your device, so that when you open the case, the circuit will break intermediately, so you won't shock yourself if you open your case for maintenance. Okay. Install power switch so that you can disconnect the power. Common sense, right? So safety is just common sense. This micro switch, I've just talked about it, and indicator lines. So this is just your daily safety. If there is a light indicating the status, so you know that my apparatus is running or not, so that you know that you should turn off your devices before you do the maintenance. Yes, this one is interesting, so I put it down. Don't wear headphones while making internal adjustment or live equipment. So that's when you are operating the radio, make sure you are doing maintenance. Make sure you remove your headphone jacks. Because headphone jacks will conduct electricity, so you may shock yourself in an accident if you don't remove your headphone jack first. And rubber mat, so that when your devices is in fault, the electricity will not run through you and go to the ground, because your body is can be act as a conductor. If you are the only stuff connecting to the ground is saying that we have 0 V. So if you can create a potential difference for them, acting as a bridge, the current will run through you and go to the ground. The rubber mat is help to insulating the current, so that you won't shock yourself if you having the electricity fault. Okay. Proper connecting lighting protections. Okay, so antenna really attracts thunders if in a thunderstorm due to its pointy structure. Yeah. So you have to really connect it to the lighting protection so that when there is a thunderstorm, you won't damage the equipment through the antenna. So that current and voltage will run through the antenna to your equipment if you don't have a lightning protection. That's why you have to ground the electricity, ground for the thunderstorm first. And apart from that, antennas will emit a very high, may emit a very high voltage if for the larger transmitter or larger antenna. So if you have a very huge setup, you have to let others know this is the place is dangerous. But this is not common in Hong Kong, because in Hong Kong the maximum power we can deliver is 100 watts. 100 watts, WATT watts. Comparing to the other countries, it is much less power. But if you have a chance to operate a very high power radio station, you have to bear in mind that prevents others from going in your antenna setup. Operating procedure. Before you go to the communications, tune your apparatus so that you don't emit signals that this is not designed. Don't emit the signal which you are not decided to do so. Tune your apparatus, tune your transmitter before doing communications. Okay, we will talk about the dummy load. Dummy load is for you to tuning your machines so that you make sure. Do we have a dummy load here? Let me check.喂，呢條我識做喎 ，Faders Jump 好似係。I don't think we have a dummy load here, but dummy load is for you to test your radio, so that if you connect your dummy load to your radio, you are not going to emit any signal. It's just like a black hole. It will absorb all the signals, so that when you test your signal, test your radio, you are not going to interfering others. Okay. 上面有。好。That's why you have to, at least for testing your equipment.
我哋真係冇晒嘅，最細呢個，我哋最細呢個，分邊咯？
之前唔係最細隻嘅咩？冇晒啊！
支火㗎好似。
Okay, oh, this is dummy load. Yeah. So we can disconnect this one and connect our radio station to a dummy load.
可以頂得住150 watts。Maximum yes 300。
And the dummy load should always have 50 ohms. Impedance. I'm thinking using the word resistance, but this is impedance, yes, impedance. So we will go through the words resistance and
呢個係咁用嘅，
跟住細啲，
健身用嘅。
做乜嘢？
有隻細啲嘅
30斤啊，大佬。
This is a large dummy load, but in reality we can have a smaller one, which is like a apple size or fist size, a size of fist, okay? Replacing your antenna for testing. Shifting or lowering the frequency, I guess it depends. It really depends. Okay, but you have to always listen to the radio before you try to connect to others. So hey, I'm going to make a connection. CQ. CQ is trying to see if anyone answering your radio, your call. Okay. You don't know if there anyone using your band, right? So to be polite, you have to listen to others first. make sure no one is using your band, and then you can start your communications, or we say going to start your CQ. If there are anyone, if there are already people using the same frequency for communication QSO, so don't try to jam in their band. Okay. But for my first QSO with others, I found that there is someone jamming my band, and
You're too kind.
I'm too kind. Yes, there is a friend of my partner, and they are talking about daily stuffs after I make the QSO. So not a very good experience. Okay.
So what do? You tell them to change the channel?
No, I can do nothing actually. Because if they are not already responding to you, then you can do nothing, right? But you can try to go to another channel and CQ and see if anyone reply to you. Yeah.
What if they go to our channel and then bug you?
You can do nothing. Yes, you can do nothing.
You can do nothing. You don't talk back. You say, hey, get off the channel.
You can talk back. You can talk back. Hey, you are jamming my channel, but not a common practice to do so.
Must be block turn B.
Yeah, that's we don't do. You can use a high power, right, to jam them back, right? No, we seldom do that. Because calling CQ is not that easy. You need some experience. So like, how should I start my conversation? Like saying CQ. Who am I? And where am I from? That kind of stuff. And if there is someone reply, how should you reply to them? So we have a through communication flow procedure. We have a procedure to follow. So if you are not familiar with it, you can listen to how others talk to the others first before you make your CQ. But in general, the Ham society is very kind. So if you really done something wrong in your first CQ, they will tell you and try to correct you back. Or they just ignore your errors. They will continue to talk to you. Yeah. But you will know someone if they are the first time to CQ. Because if you are the first time to CQ, you will speak it very slow, and you can pronounce your call sign correct. Like you are having the call sign VR2, right? So if you are not familiar with the NATO alphabets, you don't know it is Victor Romeo 2. Yeah, so we'll speak it very slowly, and you try to break your chart and try to map all the characters back. So that's why you know the opposite side is really an amateur or not. Yes. Always use appropriate speed. If your speed is too fast and the opposite side cannot copy it. But if it is too slow, just like Michael has shared, if the Morse code is really slow, it will be very tiring to hear the signal. So that's why always use appropriate speed. So the opposite side will tell you, hey, you should speed up or slow down. They will tell you about that. CW? Oh, let me see if I... Yes, because our class we have only 10 minutes left. I want to share a radio to you for how to call CQ.
就係呢個 call sign 啊！我
Let
嗰
me
次
see.
我嗰次同嗰個有個人同我傾咗輪之後，我記咗個 call sign，佢就用呢個 call sign。
假 call sign。
咁唔知係女仔啦，係咪？你有講自己喺度。
So I have to explain it first. CQ is calling anyone in the world, but you will see a DX, right? DX is distance. So so basically, if you are saying DX, CQ DX, which means that you are not going to find someone in the same zone as you. So we are two, right? So CQDX means that you want to communicate others other than in Hong Kong. Okay.
Bravo Germany 8, Bravo X-ray Mexico.
Bravo Germany 8, Bravo X-ray Mexico. Hard and night flight into Hong Kong to yourself.
Cursor Victor Romeo 2, X-ray Yankee Lima. This is Bravo Germany 8, Bravo X-ray Mike.
Yes. So you see that when they call their call sign, it is in NATO phonetics, character by character, and there is a I have to explain it about first. So 59 is signal representing the signal strength, readability and strength. So we'll go through it once again. We will go through it later time. So we just give you a taste. I just give you a taste how the communication looks like, and I'll explain the details next lesson. Okay. I will show you once again this video, and you will know all the details in it. And we have got Q cooks here. QSL means it's a short form. Q cook. So these three letters means can you receive all my signals? How it works. Okay.
Cursor Victor Romeo 2, X-ray Yankee Lima. This is Bravo Germany 8, Bravo X-ray Mike. Your single common 程度 is 5 by 9, 5 9. Very good, very nice. Over.
QSL. Thank you for hard and night from Chengdu. Your signal very strong.
Yes, we always fix these six, but never mind.
Roger, Victor Romeo 2, X-ray Yankee Lima, Bravo Germany 8, Bravo X-ray Mike. Good afternoon, Patsy. Good afternoon. Nice to meet you. You're 15, Bert.
Yes, good afternoon to you. Happy to meet you on 15 today. Hope you enjoy it and have a nice day. Hope also to meet you on this weekend Single Thailand WTH content. Bravo Germany 8, Bravo X-ray Mike. Victor Radio X-ray Yankee. DTH from Hong Kong. Bye-bye.
Roger, I forget my handle name is John. Zulu Hotel Alpha November Golf. Zulu Hotel Alpha November Golf. Nice to meet you. Have a good day. Good night. 5388. Goodbye. 再见。
Okay, so this is how a normal conversation looks like. Okay, so you see that they give a lot of information. Which wavelengths are you doing? How the signal strength of the opposite side, and where is the QTH? Where's the location they are at? Okay, so this is the details that we will go through. Sometimes we will also say that the power that I'm using now. So there are some guys in the ham society love to use a very low power to communicate. Try to use as low as they can.
QRP.
Yeah, QRP. So, so if you see this kind of guy, they will probably say that they are using a very low power. Yeah, but most of the time we will see that the other opposite side is using 100 watts, and I'm also using 100 watts to communicate, especially for DX. Yeah. So this communication time. So you see the lady is calling CQ15, which means she is seeking for others at the 15-meter wave band. 15 meters wave is 20 megahertz. 20 megahertz. Yeah. We will do the calculations later, but not today. Yeah. So you see that if you are not familiar with the flow. I remember that she is the wife of another guy. Because if you type the call sign, she is a very famous ham in Hong Kong. Yeah. So you see that in the comment. That I don't know who is this, but XMT, the wife of XMT. So if you Google XMT, and XMT is also a very famous ham in Hong Kong.
Somebody is still
Yeah.
querying whether she's from Hong Kong or not.
Yeah.
She got some Mandarin accent.
But never mind. But in ham radio we don't comment about the vowel. Yeah.
Because I noticed the Chinese guy
Chinese guy.
use non-standard NATO alphabet
Yeah.
pronunciation, right?
Yeah.
So if someone telling me the call sign this way, should I replay it in their words, or I can use the NATO?
You can use NATO. Yeah, you can use even your own words. Yeah.
Okay.
Because in the exam.
Even the guys he switch like between Mexico and Mali.
Yes.
Several times.
Sometimes they may switch, and sometimes when we do the call sign calling, Victor. Sometimes people may not realize what Victor is V, so we may change the words as Victoria. Yeah. Just depends on if the guy can recognize the word. If not, then we will try to use another word. Yeah.
Some accent cannot.
Yes, some accents cannot.
Victor properly. So I heard someone say Victor Radio 2.
Yes, radio is also common, but
Victor Radio 2 is
but
quite
in your exams, follow NATO
Yes,
reference.
of course.
Practical, you can change a bit. Yeah.
應該貴就同佢傾。
So we usually don't comment on others' accents, especially you don't know who is the opposite side, right? So this is a very bad example. You should not do the comment. Okay, and maybe I can go a bit deeper. CW is Morse code. Okay, so we have just seen an example, and we can go through how the communication should work. We use a lot of Q codes to, which is an abbreviation, using 3 letters to represent an idea, so that we use Q codes. So we have some common Q codes, which is QRZ, who is calling me, QTH, where are you from, QSL, can you receive, this kind of short form. But the Q code only consists of one question in your exam, just one question. So if you don't remember, never mind. But in the daily operations, you will find that there are some Q codes will be used more frequently. Yeah. Yes.
Can you mention those words again? QSL
Sure.
is what?
You can see that just a minute. QSL is common. Yeah. Can you acknowledge its receipt? So can you receive my signal? QTH is also common. Where are you from? Where is your location? And sometimes we will also use QRT. So at the end of the conversation, you can add QRT, saying that, oh, I'm going to stop my conversation. Yeah, but it's not that common comparing to the first two that I've just mentioned. Yeah. Let me see. No. QSB is also common, especially in distance DX. Okay. Because the ionosphere is not that stable, right? It's not that stable. It is fluctuating. So the signal they can hear may be fading. So if there's someone saying that your signal is fading, QSB, so you know that the ionosphere is fluctuating. So and the conversation will go really quick, and they will end the conversation as soon as possible, as quick as possible, because they know the weather is not suitable for the conversation for longer time. QSB. Yeah. Okay. And I guess QRN is somehow can be
Interference.
used. Interference
from natural source.
Natural source. Yeah. So in the Wikipedia they use the word static, but M is interference by human, N is by nature. Okay. The rest of them you don't have to memorize that much. Okay. Okay. So you see that the operating is just you can just ignore it. Okay. QCOOK and RST and standard abbreviation. So in our just conversation now, you can hear them. They use 73, 88. So 73 is best regards, a common abbreviation in the ham society. I will mention it next time. Don't worry. And the RST signal is to report someone. Is your signal good? Can I hear your signal? RST. Can I hear your signal? Is your signal readable? How is the tone of your key? Tone of the key is especially for CW. Let me just leave it. Okay, so the time is running short. I will just go through the QCOOK before we leave. Okay, QCOOK, 3 letters in a group. As we are using QCOOKs, there are no ATU prefix start with Q. Okay, like Hong Kong is VR2. The mainland China is B, right? BG, BA stuff. Japan is J. No one is using Q as the first letter for their call sign. It is reserved for QCOOK. Okay. At the first, it is used for military and also aircrafts. But there are some QCOOKs being adopted in the ham system. Okay. I just mentioned. So, are you going to go through all of this? Actually, no. Just remember QTH, QRZ, that kind of stuff. QSB you can So as in the conversation of just demoed for the antenna, you will say you can hear that there are someone calling QRZ, right? QRZ means that you can hear maybe you can hear some noise. Someone is calling you, but you are not confident, or you cannot hear it very clearly. So you call it once again QRZ. Is there someone finding me? This is how it is used. Okay. And sometimes you will see that's why everyone has a clock, right? Why you have to use QTR? It's because there are someone maybe doing if they are doing the DIY stuff, they are setting all the equipments on their own, and they are not purchasing all of them. So they don't know maybe their exact frequency is what. The frequency they transmit and their target frequency may varies. So they need the reply from the others. Okay. Yes, the frequency varies. So that's why we have this kind of code. So we'll stop here. Next time we will come back with RSC system. Okay. RSC system basically is responding how strong your signal, how clear that I can hear your signal. Very nice today. We have go through 60 slides today. Good. Yeah. See you in the next lesson.